Hey guys, welcome to week 2 of distance learning. Hopefully it's going well for you. Today our video is going to be about Unit 8, Section 6, which is angle relationships in, on, and outside a circle. So the first important theorem that we're talking about, if a tangent and a chord intersect a point on a circle, so our tangent is this line here, and the point is A. So point A is the tangent point. Remember, a tangent line is a line that intersects a circle at exactly one point. A is the point of tangency, and then the chord here is AB. It's the angle formed is half the measure of its intercepted arc. So the intercepted arc is from B to A, or we can go in the opposite direction, which is also from B to A, but it's the long way around. So in this next example, you'll see how they work together. So here we have angles 1 and 2. The intercepted arc measure is this right here, the 172 degrees. So angle 1 is half the measure of that arc. So what we're going to do is take 172 divided by 2, and we are going to get 86 degrees would be the measure of angle 1. Okay? Now, if we know angle 1 is 86, you have to remember when you have two angles that are adjacent and they form a straight line, that's called a supplementary pair, a linear pair. And what that means is they just add up to 180. So to find angle 2, what we can do is just take 180, subtract 86, and we get 94. So 94 degrees is going to be our answer for angle 2. All right. Here we have different relationships. This is where the title comes from, relationships on, inside, and outside of the circle. So the very first case is if two lines intersect on a circle. So remember, what this forms is an inscribed angle. An inscribed angle has 2 points opposite of the vertex, which would be these 2 points right here, and they form an arc, which in this case is going to be the value of A. And then here is our angle. So how this works is the measure of angle, we'll call this angle 1 right here, is equal to 1/2 A. And that's something that we've already learned. And remember that we can also go the other way. A is equal to 2 times the measure of angle 1. So there's two different ways we could think of that. And that's something that we learned in our last section. The other part is if two lines intersect inside the circle, not at the center typically. The formula for this is going to be, here's our angle 1. We're going to say the measure of angle 1 is equal to 1/2 A plus B. Basically what this is finding the average between the two arcs A and B and their values. Another way we could look at this, measure of angle 1 is equal to A plus B divided by 2. Both of these formulas are the exact same thing. Multiplying by 1/2 or dividing by 2 are the same thing, but make sure that you add the values first before you multiply or divide, because those values are in parentheses. So that's what needs to be done first. And then case 3 is where two lines intersect outside of a circle. Notice we have two arcs again. We have arc A and arc B. We always want to assume that arc A is the bigger arc, which makes sense because it looks bigger. And we are trying to find angle 1, which is right here. So this is angle 1. So the measure of, the measure of angle 1 is equal to 1/2. Rather than add this time, we're going to subtract. A minus B. Or measure of angle 1 is equal to A minus B divided by 2. Again, same thing for these equations, just two different ways to write it. So the biggest difference between these two situations for case 2 and case 3, if it's inside, you add A and B. If it's outside, you subtract. And if it's exactly on, like case 1, then you just got to take half of the value of A. So let's actually put this into practice here. So what is the measure of angle 1? Angle 1, notice it is inside of the circle. So then we have case 2 for this problem. So our formula is measure of angle 1 is equal to, I like to think of it as a plus b all divided by 2. This case, we like to assume a is the bigger angle, just a good habit. So 120 plus 98 over 2. We add the 120 and the 98 first, and that is going to give us 218 divided by 2. So the measure of angle 1 is equal to 109 degrees. Okay. Again, we just basically found the average of those two arcs. Another thing I want you to keep in mind, because you're going to see this in some of your problems, if you know that's 109 degrees, the angle directly below it is also 109 degrees because those are vertical angles. And then the angle on the side right here has to be supplementary with that angle, making it 71 degrees. And the one across from that is also 71 degrees. Okay, next example, we want to calculate the value of x. This time, we know the angle here, 45 degrees. This is going to be a case 3 situation. In this case, we know what angle 1 is. This is our angle 1 right here. So the measure of angle 1 equals 45 degrees. So in our formula, remember it's measure of angle 1 equals a minus b divided by 2. So we need to fill in the different pieces here. We know angle 1 is 45. This time a is the bigger angle, so 170. We don't know what b is. That is this arc right here, the value of x. That's what we're trying to solve for. But x is the only variable. So the first step that we would want to do here is get rid of the 2 on the bottom. So we're going to multiply both sides by 2. 2 times 45 gives us 90. 170 minus x. We want to get x by itself, so let's subtract 170. We get negative 80 equals negative x. Divide by negative 1. And we get x equals positive 80 degrees. Which, if you're getting a negative degree answer, you probably did something wrong. So make sure that you got a positive angle there. Okay. On to the last set. Calculate the value of x. So same situation here. We know that 61 degrees is our angle 1. So just like the last time, remember our formula. Measure of angle 1 equals a minus b all over 2. This is an outside situation. So this is our a, this is our b, and this is our angle 1 right here. So 61 degrees equals 10x plus 1 minus 5x minus 1. I'm going to put all of this in parentheses because I got to do this first. Divided by 2. Now this is where it gets a little tricky. You have to remember that with this negative sign, we are subtracting the entirety of 5x minus 1. So we actually have to distribute the negative sign to both parts. So the top becomes 10x plus 1 minus 5x plus 1. Because when we take that negative times a negative, you get a positive all over 2. 61 equals, combine like terms, 10x and minus 5x gives us 5x, plus 1 gives us plus 2 over 2. So the first step, multiply by 2 on both sides, gets rid of the 2 on the bottom. We get 122 equals 5x plus 2. Subtract 2, subtract 2. 120 equals 5x. And then we have to take 120 and we divide that by 5 to get the x by itself. And I'm just going to write the answer up here. 120 divided by 5 equals 24. So that is going to be our answer on this one. Next problem, we want to calculate the values of x and y. So the first thing to note, it's probably going to be easiest to start with x, just like usual. So x is inside, I need to get rid of that. X is right here. We have the 77 and the 171 are the two arcs that are across from the x. So if we want to find x, we can take 171, add 77, and divide it by 2. This is just like case 2 from our set up here. So 171 plus 77 is going to give us 248 over 2, which means x is going to equal 124 degrees. So there's one answer. Now y. Y is this angle right here. Remember, we got to figure out what's the intercepted arc. So the intercepted arc that corresponds to y goes from here all the way down to this point right here. So it's the 30 degrees, the 171, and then we got to take half of those two together. So I'm going to add 30, 171 divided by 2. So I'm going to get 201 divided by 2, which equals 100.5 degrees. So y equals 100.5 degrees. Okay, and that's the last example. Please continue to ask questions and let me know if you need help with anything from here on.